right, welcome. Going over entry 2 today, atoms in the periodic table, building off what we did yesterday. So yesterday we talked about matter and how whether we're looking at a storm, which has lots of different types of states of matter in there, we got solid, liquid, gas, and plasma present, that all those states of matter are composed of atoms, and atoms represent the different elements on the periodic table. So why don't we pause here and this what's it called, table. Take a moment to look at this table and identify them. I'm not going to talk through each of the vocab terms specifically, but take a moment, see if you can figure it out. So just Google them or see what you know, and then hit play and resume the video. Okay, so we're going to start at the bottom here. Measure of amount of matter or stuff is called mass. Okay, it's different than weight. Your body weight is the amount of mass you have times the force of gravity, or the acceleration due to gravity. We got 3 types of elements, which you saw last week when you were preparing your periodic table. We got metals, nonmetals, and metalloids, and they have different properties, conductors and non-conductors or semiconductors. We have rows. Those are called periods. I like to think periods are found at the end of a sentence, so they run horizontal, and group has the P. Those are columns because the P goes down. All atoms are made up of protons, neutrons, and electrons. Protons and neutrons are in the nucleus. Electrons are outside. Positive charge, negative charge, no charge. Atom and element. Okay, so atom is one single molecule. Smallest unit of an element that makes the properties. Meaning, an example, carbon has 6 protons. If I were to take those protons and break them up, it would not be carbon anymore, and it would no longer have the properties of carbon. Okay. Every atom of carbon has 6 protons. So if I change protons, I would change the type of atom that's there. So I can't break it up any smaller. But if I had a block of carbon and next to it was mixed in with it was maybe some, let's say sodium, you could do a chemical reaction and break those up and separate those, or a physical process. So elements cannot be broken down by chemical reaction. So I can't take an element of, or an atom of, or a block of carbon, do a chemical reaction and break it up. It's all carbon. But if I have other ones mixed in there, I can. So every day we organize things. We organize our notebooks, our lockers, our dressers, our lives, whatever it might be. Okay, so think in your mind, like what's one thing you organize and how do you decide to organize it? Why did you organize it that way? Think about yourself for a second. I'll give you an example from my life. So in my closet, I have things separated by like shirts that I have hanging. I have long sleeve and short sleeve. And then in the long sleeve, I have like casual long sleeve and more formal long sleeve. And then on the other side, I have like t-shirts, and I have more like nicer t-shirts and more workout type of t-shirts. I have exercise pants and jeans in separate places. So even though that maybe I have all my pants in one place, they're separated even further. So if I look at the periodic table, it's organized in a specific pattern as well by increasing what we call atomic number. And that's just the big block number that you see on the periodic table. And every block on the periodic table is a different element, which also contains an atomic symbol and atomic mass. So when I look here, number 1, that's hydrogen. That's its atomic number. Going to 2, 3, all the way up to 118. Some periodic tables may not have some of these elements there for various reasons. Okay, but you have the atomic number, the element symbol, and that's gold right there in the name, and the atomic mass. So every element is unique in certain ways, and they're each assigned a certain number. But the organization that you see here is not random. Atomic number, the number 1, 2, 3, 4, going back to our carbon, number 6, the atomic number is the number of protons in that element. So every element has a unique number of protons, and that's what separates it from all the other elements. Okay. Furthermore, when you did your, what was it called? When you did your periodic table last week, you saw these were the alkali metals, the alkaline earth metals, the transition metals, the lanthanide and actinide metals, your inner transition metals, your metalloids, your nonmetals, halogens, noble gases, and so forth. Okay, so we have all these different groups. Even though all of these things over here except hydrogen are metals, they all have slightly different groups. That would be like shirts. I have long sleeve formal, long sleeve casual, short sleeve casual, short sleeve formal, so forth down the line. Okay. So when we're talking about what makes an atom unique, there's two parts that we're looking at. We're talking about the structure of an atom, what it's made out of. In the middle is something called a nucleus, which has neutrons, no charge, and protons, positive charge. So if I were to ignore all these things on the outside, you'd say the nucleus has a positive charge. And if you just look at the size of electrons around it, which one is bigger by particle size? The nucleus particles or electrons? You'd say the nucleus particles, right? Because they're clearly bigger. So if we go back to our piece here, we notice that neutrons and protons have a mass of about 1, and electrons have basically no mass. So comparatively speaking, electrons have no mass. Okay, so you should get like a rough sketch of something similar to this in your notes. But if you look at which of these takes up the most space, you'd say, well, for sure it's the electrons. It'd be like saying in our solar system, what takes up the most space, the sun or the entire solar system? Well, the entire solar system does, even though the sun is in the center and contains a lot of the matter and is way bigger than everything else. Okay. So where are they located? Protons and neutrons are in the nucleus, which gives the nucleus a positive charge. Looking at it right here, there's kind of a cluster of those things, and then surrounded in orbitals are electrons, where the negative charge is found. And electrons are what's important in bonding. So if I look at this atom, this is lithium. It has 1, 2, 3 protons. And if I were to look at my periodic table, over here, number 3 lithium has 3 protons. There's 4 neutrons here, so in the nucleus I have 7 things. And if I look over here at lithium, if you can't really see it, it's like 6.9. So the mass of lithium is about 7. And we'd say 7 grams, actually. Okay, so, and that represents the average number of particles in the nucleus. And that's what you see here. 7 particles in the nucleus, 3 protons to determine that it's lithium. And since I have 3 protons and 3 electrons, we'd call that a neutral atom. Not super important at this moment, but we'll get there later. So pause right here. This is a typical element box. It just contains some extra information, but you should be able to pick out certain things, and I'll talk through that in a second. So pause here and write those stuff down. All right, so electron configuration. Don't worry about that a whole lot. That's just telling you that in my first ring, I have 2 electrons. Go back here, 2 electrons. Second ring, I have 8. Third ring, I have 14, and then after that, I have 2. We'll talk about how that happens later. I have my atomic mass, which is the average of all the isotopes. Don't know what an isotope is yet. No big deal. I have my atomic number, which is number of protons, common ions, going back to plasma, charges that it forms, and then the symbol, that's iron. So go through and I want you to label the parts of this diagram real quick, and then we'll talk about it in a second, so pause here. Apologize for the sloppiness, but here you got the whole numbers. That's your atomic number, which is the number of protons, remember. You have the average, the decimal number, that's called your atomic mass. You have the atomic symbol, and the name of the element, and then there's some extra stuff here. This right here is your electron configuration, but don't worry about that a whole lot. Okay, so let's talk about some generalities from the atoms. So here, the number of protons determines the number of, or the type of atom. So you have 1 proton, 1 proton, 1 proton. Notice they're all hydrogens. Okay, but some of them, I have 1 neutron and 2 neutrons. That changes the mass. 1, 2, 3 is the mass. 1, 2 is the mass. Or 1 is the mass, and that's the top number here. We call that the mass number. Okay, so I'm going to add that in right here. Actually, I take it back. Okay, I'm not going to add mass number because we're going back to that later. So in general, unless otherwise noted, we assume protons and electrons are equal. So 1 and 1 gives me an overall charge of 0. Positive 1, negative 1. Add them together, 1 minus 1 is 0. So protons have to be the same if I change it, but I can change the number of neutrons or electrons. So electrons exist in these things called orbitals, and up to this point you had seen them as circles. And that's not exactly true. So it's more like a 3-dimensional shape like this is a sphere. So I didn't mean for that to look like the Pepsi symbol. Okay, these are all three-dimensional shapes. So you have your X, Y, and Z axis. So electrons are somewhere in like that bubble or that balloon. Think of them like kind of like balloon shapes. Okay? And there's different shapes. We'll talk about that a little bit later, but maybe not at a ton of length this year. So mass of subatomic particles, protons and neutrons is 1. Electrons have no mass just because it's much, much smaller. So you have your charges and masses there. So how do I know how many protons, neutrons, electrons are in an atom? Well, you can look at the element symbol and box and figure it out. If we're assuming it has an overall charge, that means two things have to be equal. That would be those guys, protons and electrons. Both are equal to the atomic number. So this right here tells me that I have 4 protons and 4 electrons. Okay? And an atomic mass, you got to round it. So this would be 9 minus atomic number 4 gives me 5 neutrons. Okay, so you got to round this number right here to the nearest whole. In this case, it's down, but it's not always down. So this is just some hypothetical situations. If I were to change a proton, the mass would change, the charge would change, but so would the element. The identity would change. And that's the biggest thing for you to understand right now is that protons determine identity. Electrons change charge. Electrons change charge, causing ions. Going back to the plasma, ionization is electrons being lost or gained. And neutrons change mass. It's called an isotope. So it'd be like if all I did was eat pizza for the next 18 years of my life and I gained a little weight, I'd still be me, but I'm a different mass now, and that'd be called an isotope. So not a ton of things to take away from this. I know there's a lot of text here. The modern version of the periodic table was developed by this guy named Dmitry Mendeleev. And the coolest part was that he organized the elements by properties. And based off of that, he realized there was a lot of undiscovered elements, and he was able to predict the characteristics. So when you think about a metal, what are some of the things they have in common? They're shiny, a lot of them. They conduct electricity. Maybe they're malleable or easy to bend. He was able to predict properties based off of this. And the reason why is because elements in a group, so all these elements right here, they have similar properties. So you should add that to your notes, is that groups, they have the same properties. Okay, same properties. That's the biggest thing there. Okay. So I want you to take a moment to practice, choose an element and draw it in there. I'll just check that when you turn in your homework. So choose any element, copy it in here, and then go through it. Actually, let's all do one together. Let's do chlorine, Cl, mass 35.45, and atomic number is 17. Why don't you use all that to figure this out, and pause. Protons is 17, electrons is 17, and neutrons is going to be 18. 35 minus 17. Okay. So I'm just going to do one of these, and then we'll go from here. So potassium, letter K, its atomic number is 19. It's in the fourth row in the first column. Its number of protons is 19, electrons is 19, and neutrons is its mass, which is 39.09 minus 19, which is going to give me 20, and it's a metal. Okay, you should try the rest of those. The last thing we're going to talk about here is that ions are formed when atoms gain or lose electron, and since electrons have negative charge, if I add an electron, it gets a negative charge. If I add 2 electrons, it gets a negative 2 charge. If I subtract an electron, I get a positive charge. If I subtract 2 electrons, that should be 2, I get a positive 2 charge. So by adding a positive or negative symbol next to the upper right hand corner, that's how we show how many electrons are gained and lost. Okay, so let's look at an example here. So tin is Sn is tin, and it gained 2 electrons. Chlorine, lost 2 electrons. Here it gained 1, here I lost 3, and here I gained 2. And lastly, you're calculating protons, neutrons, electrons here. and then trying one of these. So remember the +2 here is going to impact your electrons.